in this class we are going to be looking at equation of motion. Now the first thing is that we only have just 4 equation of motion. The first one that we have is v is equal to u plus at, right? And that one we also have x is equal to ut plus half at squared. We also have our v is equal to, that is v square is equal to u square plus 2ax. And we also have the last one, which is x is equal to half open bracket u plus v close bracket t. Now these are the 4 equations of motion that we do have. Now let's look at this. You know that this equation of motion can also be referred to as to our SUVAT equation. SUVAT equation. You can also call them SUVAT equation. Yes. Now looking at this class, we need to understand them in basic. You only want to know how to derive this equation. All right. Now we said our x here is standing as the displacement. Our x is standing as displacement, which is m. Are you getting that now? Our s is standing as displacement. And we said our u is standing as the initial velocity. Our u is the initial velocity, which is meter per seconds. And we also have the v. The v is the final velocity. The final velocity, which is also mx minus 1. And we also have our a, and our a is the acceleration. The acceleration. All right, and we said our acceleration is mx raised to power minus 2. And the last one, which is t, is standing as the time. The t is standing as the time, which units is seconds. Now after knowing this, let's try to derive each equation. Let's derive each equation. Now looking at this equation, we want to derive this our equation 1. The equation 1, which is this our equation 1 here, which is v equal to u plus at. How can we derive it? Now this is where we are going to move on. Just listen attentively so you can understand very, very well. Alright, to derive this equation 1, which is v is equal to u plus at. To derive this is how it is before. The equation was like this. It was arranged like this: a is equal to v minus u divided by t. Now looking at something like this, we need to rearrange it to give us in this format here. So it will become that we are going to cross multiply this. It will become v minus u is equal to at. And we need to make our v the subject of the formula. Therefore v is equal to, if minus u should move to the other side, to become u plus at. Therefore this is our equation 1. I hope you understand as we do that now. That is that on the first equation of a motion. All right, let's move on to the second one, and I need you to understand that also very, very well. All right, now let's look at the second equation, which is the second equation here is x is equal to ut plus half at squared. Now how do you derive equation like this? Now equation like this is known as velocity time graph. Why do I call it VT graph? That is velocity time graph. We always say that displacement is equal to VT graph. Now to understand this basic, we need to use a diagram to explain and derive this formula out. Now let's just give this as an example. Let me just say something like this. All right, let's say we're having something like this, and here we are having this place as our initial velocity, that is u, and here we're having here as v, and let's say here is our time, that is per second. We are plotting the velocity against time. Here is our velocity, which is meter seconds per 1, and here we are having our t here. Hope you are getting what we are doing here now. All right, then we said our u here, which is the initial velocity, is having a rectangular shape here. All right, a rectangular shape here. Then from this place to the other side is forming a triangle. Is forming a triangle. You want to derive this formula for this. All right, now after getting to this, note we said our displacement is equal to velocity time graph. Okay, now whenever I'm talking about this, that is displacement is equal to area under velocity time graph. That's what we want to derive for this second equation, which is what s is equal to ut plus half at square. Now to understand this, we know that let's now get what's the area of a rectangle here. The area of a rectangle here is what? The area of a rectangle is what? The area of a rectangle is what? Length times, that is our length times breadth, and here we're having what? U and t, that is breadth times what? Times length. So that's the area of a rectangle. Therefore here will be what? Therefore the area of a rectangle here will be what? Ut, that is what? Our length times breadth. Note we are working with what? We are working with let me just cancel this place. Note we are working with what? Displacement, and we said the area of what? Of the area of a rectangle is what? Length times breadth, which is what? Ut. Are you getting it? Ut. Now that we are having ut plus, now what is the area of a rectangle? That is half base times height. Half base times height. Therefore our area of a rectangle will become what? Half, and the base we are having what? V and u, so it will become v minus ut. That is what the area of a triangle. I hope you are getting as we are deriving it now. You can see we are coming to this side now. Now looking at this now, note something, that in the previous equation that we solved, we said that v minus u is equal to what? It's still the same thing as what? At. Note that we said v minus u is equal to what? Note, let me just put it here. Note, v minus u is equal to what? At. Equation 1, go through it and you understand it. Since you know that v minus u is equal to at, therefore anywhere we are seeing v minus u, we are going to input what? At. Therefore our x here is equal to ut plus half at open bracket the t that we are having. Therefore we should solve it to become s is equal to ut plus half at square. Are you getting it now? This is what? The second equation. Equation 2. Second equation. Let me just put it like this so you can understand what we are doing. This is what the what? Second equation. Now okay, let's move on without wasting much of our time. Let's move to the what? To the third equation. Alright, the third equation we are looking at now is when we said v is equal to u square plus 2ax. V is equal to u square plus 2ax. Now looking at this, we can see that we are having square here, and to solve something like this, we are going to derive it from this equation, which is what? V is equal to u plus at. V is equal to what? U plus at. Now note that this equation here, okay, so the equation here is what? V square is equal to u plus 2as. That's the equation. V square is equal to u square plus 2as. Now to derive this equation, we are going to derive this equation from the equation 1, which is v is equal to u plus at. All right, now looking at this, let's square both sides. That is square and square this side. All right, now after doing this, we then said v square is equal to, if we should expand this one will become what? U. Let me just solve it so you can understand as we solve it. U open bracket u plus at plus at open bracket u plus at, because we are doing what? We want to square multiply this 2 times because it has was square. All right, so here will become v square is equal to u times u is going to give us u square plus uat plus at times uat plus at times at, a square t square. I hope you are getting what we are doing here now. So after getting to this point, we said v square is equal to u square plus uat is going to give us what? 2uat plus a square t square. Now here is balanced already. Then we need to what? To find and fight with these 2uat and this our a square plus 2 square. Now looking at this, we can factorize something out, which is what? 2a. We can factorize what? 2a out. Now to solve that, this will become what? V square is equal to u square plus 2a open bracket ut plus half at square. I hope you understand what we did here now, because let me just explain. So we factorize our 2a out because 2a times ut is going to give us what? 2uat. Are you getting that now? And we said 2a times half is going to give us what? A square. That is 2a. 2a times half a is going to give us what? 2a square. That is a square, because 2 cancel 2 and remain what? A, and a times a is going to give us what? A square, and we're having t square. You can see it's still the same thing as this. We only factorize this out so it can be what? Balanced. Now looking at something like this, this has what? Been balanced, and we said note that our x is equal to what? Ut plus half at square. Looking at what the second equation we derive, therefore anywhere we are seeing ut plus half at square here, we are going to input it as what? X. Therefore the equation will become v square is equal to u square plus 2ax. Therefore we have already derived for the what? For the third equation. This is for the what? The third equation. I hope you understand what we did here. Now it is very, very simple. The equation are what? Very, very simple. Let's move on to the next equation. Alright, the next equation we are looking at now, which is the fourth and the last one, is what? When we have something like this, x is equal to vt, and this v you are seeing is what? Average velocity. And we also having the next one, that is average velocity, that is v bar, is equal to half open bracket v plus u, or we can say u plus v. Let me just write it as u plus v. Now looking at something like this, we said our displacement is equal to what? Average velocity times time, and average velocity is equal to what? Half open bracket u plus v. Now since we are having something like this, that is, we need to understand something. We said our displacement is equal to what? Is equal to what? Now looking at this here, we are going to what? This is very simple. This last equation is what? Very, very simple. Since we're having s is equal to average velocity times time, and we're having our average velocity as what? Half open bracket u plus v. Therefore we are going to input or substitute this equation 2 to what? To our average velocity. Therefore anywhere we are seeing average velocity, we are going to input what? Half open bracket u plus v. Therefore here it becomes s is equal to what? Half open bracket u plus v close bracket t. Therefore this is what? For the equation 4. I hope you understand it now. This is for equation 4. You can see it is very simple to solve, and there is no what? Nothing to waste much time on it. So in summary to all what we have been doing so far, just know that the equation we are using is what? SUVAT. SUVAT. And we said our S here is what? The displacement. Our U there is what? Is the initial velocity. While our V there is what? Is final velocity. And our A is what? Our A is acceleration. While T is what? Time. Now note something, that our SUVA, which is what? Suva, are what? They are vectors. All these are what? Vector. But time is what? Scalar. Time is what? Scalar. You can see the difference between those two. SUVA are what? Vector, while time is what? Scalar. So this is where I'm going to stop for today's class, and next video, just subscribe to our YouTube channel and understand more on this. Goodbye.